Okay, hello guys, and welcome to the first part, um, to the introductory part of my series learning Java. In this video, I will make some introductory remarks. I'll give you some tips on how to watch this course, this free YouTube course, and I will explain the concept of the course. Okay. The first advice I give you is watch this course on 1.5 to 2 times speed, because otherwise it will get very annoying because I need to do some typing, I need to do some drawing, and that just takes a little bit, and I'm sorry, but I don't want to edit all the parts out and speed them up because it's a little bit too cumbersome, I think, and this is a free course, so what did you expect, right? Yeah, so this is something I'll advise to give to you. The first question I want to ask is, why Java? And you might know that, I'm sorry, I'm a bit thick, that Java is pretty unpopular. If you ask people on the internet what they think about Java, if you ask like not so much experienced programmers, but just like the general tech bro, he will tell you that, hey, Python is a way better language, and if you really want to do some computationally expensive stuff efficiently, you can use C or C++ or even Rust. But Java isn't that popular. So yeah, let's put that here. And we can already once again ask ourselves why isn't Java that popular? And I think primary answer is it's a lot of boilerplate code. Yeah? Java forces you to write a lot of boilerplate code. This is one reason, and I'll explain it further and in more detail in a few seconds. And also Java forces you to be OOP almost, let's say almost all the way. Okay. And this is also a problem because some people really don't like the object-oriented paradigm. And if you don't know what this means, okay, then I'll explain it further on. The introduction is also mostly aimed at those people who already know a little bit of programming, are already a little bit familiar with concepts like OOP. But don't worry, we'll talk about them in the following videos. And these two reasons are probably the most talked about when people try to justify their judgment that Java isn't that good of a programming language. First of all, let's maybe look at the boilerplate critique. Okay. We could say, let's look at a simple Hello World program. Yeah, Hello World program we know and love. That's like just to get started in a programming language, you just write a little program and execute it. The simple Hello World in different programming languages. Yeah? For example, Python. Yeah? In Python, if you set up the interpreter, Python interpreter, you can just write, and that's it. Okay. So you see a big advantage of Python in comparison to almost any other programming language or scripting language is simply it is very concise. It's easily readable. Yeah, that's a big upside of Python, of course, because everybody can understand, everyone with a even fainting familiarity with programming can understand that if you interpret this statement, if the Python interpreter interprets this statement, it will just print out hello world, right? And now look at Java, for example. Yeah? Now look at Java. First of all, you have to declare a class, because as I said, Java is forcing you to be OP almost all the way, okay? And this means you can't write a main function outside a class. Everything has to be in a class, so to say, okay? So we say class hello world. Let's call this class hello world. You might ask yourself, why do I have to declare a class when I just want to print out hello world? And of course, real programming is not writing hello world programs all the time, right? So every real business application, for example, has a complexity to it that almost immediately justifies it being in a class, okay? So this is not a problem if you look at what programmers actually do. But in a case like this, it should be possible just to avoid it, and the compiler in this case, because Java is an interpreted language, compiled language, it should just be possible to make it maybe as simple as Python, but it just isn't. You have to declare a class. You can give it this class a certain name. Then you have to define main function. Okay, this is the entry point. This is also when you compare with Python something Python we don't know in Python. Of course, there is this if underscore name underscore is equal to main, but don't misinterpret this if condition for the main function, because the main function is the entry point of our program. Let's imagine our program that gets compiled to bytecode in Java always has to take up certain system resources, so for example memory, and it also has to be called from the operating system. Okay, and this is why we need an entry point in Java, but also, for example, in C or C++ or yeah. Okay, this is just more. If you look at programming languages which are more low level than Python, you need to define this entry point. And in the end, everything your program does is happening in this main function. Okay. Of course, we will talk about this in more detail as well. So let's just keep on moving. And then we have to write public, and this is something of a meme in programming circles, okay? Because it's very verbose, it's very much boilerplate code, and this is something people just don't like, and I can actually understand it. I don't like it myself, okay? So I don't want to sell you on Java like a salesman. I don't care in the end. I actually think it's a decent language, it's a good language, and especially it's a very it's a language where there will always be a high demand for, because every enterprise system, every business system is written in Java, so you won't have any problems finding a job, for example, which is a very good thing. I will come to I will speak about this a little bit more detail later as well. But of course, you see, it's a much boilerplate. You have to write this class. Now you have to write public, static, void, main, string, args. Okay, now we have defined our main function. Okay, and once again, this is the entry point to our program. We'll talk about that later. And now I have to write system.out.print, and for example, hello world. Okay, and just look at this. Yeah, this can be very intimidating to okay, let's just delete that. This is why Java can be very intimidating, because everybody can understand what this statement right here does. Okay, but here Java forces you to declare this class. You might not know what the class is if you're not familiar with object-oriented programming. And you have to write some access modifiers. What does static mean? You have to specify the return type of this function, which is void, meaning the function doesn't return anything. Then you pass an array of string called args to this main function. You don't use it here, but still you have to. Then you write system.out.println hello world. So it seems way more complicated in Python, and in a sense it is. Okay. The thing is, if you actually become even a little bit advanced in Java, you understand what's happening here very easily. And we will talk about what access modifiers are. We will talk about what static means. We will talk about data types and data structures and what a function is. Okay, but the problem when teaching you programming is you have to start somewhere. And I know for now this doesn't seem so nice. Okay, and in a sense it isn't that nice. Even and as I said previously, like complicated, if you want to design a little bit more complicated software than a hello world program, of course it's always useful to put them in classes, right? But even then, there's a lot of boilerplate code. So for example, if you want to program, I used to do this when I learned Java, tic-tac-toe. I can program tic-tac-toe in Python like 50 lines of code. It took me 150 lines in Java. It's very cumbersome. Just reading user input, for example, you have to declare a scanner object. And yeah, so Java is in that sense more complicated, more boilerplate code. Okay, and you might not like, if you're into functional programming, for example, you might just not like object-oriented programming paradigm. So yeah, I think I talked about the downsides of Java now for enough time. And now we can ask ourselves, why should Java be possible? I'm sorry. Why should Java be popular? Possible would be funny. Okay. Let's talk about the upsides maybe a little bit. Okay. I think that Java is Java is very well balanced language. Okay. It's right there in the sweet spot, so to say. What I mean by this is simply, for example, look at performance. Yeah? Z is, okay, you can look at the assembly, for example. If you don't know what assembly or Z or anything like that is, you can also skip this part. But just to give you a more concise notion of why I think Java should be more popular and what I mean by saying that Java is a very balanced language. Z, yeah, Java, and then Python, for example. Yeah? Of course, these are, I could have taken any other programming language except Java because we want to talk about Java, but what do I mean by this? Okay. Or maybe let's talk about abstraction first. Abstraction is a very important, I'm sorry about that, very important concept. By that I mean, if you want to write a program, right? You don't want to write an operating system on your own and then run something on it. That would be way too difficult, way too complicated for most of us. So what people in computer science do, they create abstractions. Okay, and abstractions, you can understand abstractions as generalizing a little bit. Okay, because okay, I don't know how an operating system works. Yeah, but I know there's a functionality which allows me to print out to the standard output of the operating system, to the console, to the terminal or something. Okay, I don't have to wonder how this actually works. I don't have to look in the source code of the operating system, for example. Maybe I can't even, but I know, okay, there's this function. I can call it. I know the input. Maybe I have to give it an input stream or something like that, and I know what it does, this function. Okay, and now you can look at maybe to give you a better understanding. Look at this print hello world. Okay, of course in the background this is a pretty complicated stuff that's going on here, right? Because the interpreter or the thing interpreting this Python script, okay, has to call the system, it has to print out, it has to do something with standard output streams. But you don't have to bother about that because you just know if I want to print out something to the console, I just use print, and I can pass this a string, in this case simply hello world, and that's it. I don't have to know that much about the underlying system structure, for example. I don't have to, if I declare a variable in Python, for example, I don't have to think about memory at all, memory management at all, okay? And this means Python is very highly abstracted. The more you have to think about like the underlying system, the more you can't just abstract away the underlying system. For example, in assembly, you have to know the CPU architecture, for example. Yeah, in Z, you have to do memory management. For example, if you want to allocate space on the heap, okay, you have to malloc, you have to free. There can be pointers. The memory management in Z is what makes C such a complicated and buggy language. Okay, but of course, this means less abstraction, as in assembly and C, for example, also means less overhead. It means better performance. Okay, you will never write a program in Python that is runs faster than Z or faster than assembly, because the less abstraction, okay, the more, so to say, control over the fine-grained details of your program when it comes to memory, for example. The more complicated this, or the more, not complicated, but the more buggy, potentially buggy the software becomes, the more mental overhead there is. The mental overhead of memory management is really intense. Okay. Of course, it comes at the price of performance. And Java is in this sense right in the middle spot, because in the sweet spot, I mean, because I think Java, by being so object-oriented, actually, is a good abstraction just between Z and Python. Of course, Java isn't. You can read, of course, Java code readers is very much boilerplate code, but you can understand what's going on here if you have a decent understanding of programming. You can understand this is a class, has a world, inside of that class, we have to define a main function. Through the verboseness, it becomes also very easy to understand for people. And in, for example, a business setting where people have to work together, right? It's very important people write understandable code for other people. Okay? This is something that doesn't get talked about enough in my mind. So Java is fine in this way. You can read it easily. There is no memory management. There are no pointers. There is just simply object-oriented programming in its beauty and in its downside, right? But of course, Java is still more complicated than Python. And let me clarify that I mean from low to high abstraction. And I will talk about abstraction more when we talk about functions and classes and stuff like that. But for now, I think you have an intuitive understanding of what I mean by high abstraction. So assembly is very low in abstraction. C is also pretty low. Java is in the sweet spot in my opinion. Python is of course at the other end. It's very highly abstracted. It's very easy to write Python code, but you don't have like fine-grained control over data types, over the memory. You don't even get compiled. A Python script doesn't get compiled to bytecode in the way a Java program does, for example. So yeah. And from this, let's say, level of abstraction, many things follow. If a programming language is low in its level of abstraction, it's always more performance. So like look at performance, and I talk about performance in a very loose sense here. Okay, let's just say you want to calculate the Fibonacci sequence for very large n, and the question is how fast are these languages if they're actually how fast are these languages? Okay, so if I write a program that does this in assembly, how fast it is compared to Java, for example. And here you can see the same thing. It's the same as above, okay? Simply because you can fine-tune stuff, you can make interesting heap allocations and more efficient heap allocations. Assembly, Z are the most performant. Java is once again in the middle spot, and Python is very slow, okay? Maybe we should talk later about what I mean with performance as well. But this text document will grow organically. Yeah. Okay. The ease of understanding, the easy to understand. Okay, that should also be clear. How easy is it to understand and communicate? Okay, so if people are working together, how easy is it for them to understand the source code, and how easy is it to communicate each other just by writing the program what is going on? And I think in that regard, okay, you can say Python is also very readable, but not in the granular detail that Java offers. So I would put Java right up there. Then C, then assembly. You don't want to write a business system in assembly, believe me, you don't. Of course, it could be done in C. Yeah, but you can see this is a very big upside of Java when compared to Python, for example. Demand. This is just like, okay, let's compare people who can program in different programming languages. How high is the demand for their work, right? Should be pretty obvious what I mean with that. And Python and Java, and you can Google this if you don't believe me, okay? Are just up there. Python is a very popular language nowadays, and if you have not so data intensive application, you can actually write a good business application in Python. That's no problem. But for example, if you're a big insurance company, you can't write the business system in Python. It just isn't done. Or maybe you could do it, but it isn't done because all these legacy systems they are in Java. Java is just very in demand. That's what I want to say in short form. And then C and then assembly and stuff like that. So this is another upside of Java. It's high demand and it always will be because of all these business systems. 1 second. So I'm sorry. Yeah. So let me think about. We could also say. Yeah, okay, I think that's enough of the question about Java. There are some downsides, there are some upsides. In general, Java is a very well-balanced language, and what I mean by this, I just specified by talking about abstraction performance, how easy it is to understand and communicate stuff in these programming languages, and that is simply the demand. So yeah, I think it's a very rounded picture of how you should learn Java, I guess. I'm not a snake's oil salesman, which I want to be honest with you guys. And yeah, and I think Java is a beautiful language. I will also put in the comment section an interview of the guy who actually invented Java, who wrote the Java virtual machine. If you don't know what a Java virtual machine is, okay, you don't need to know for now. Yeah, and now about, okay, maybe this video is already pretty long. I think I'll talk about the concept of this course, of this free YouTube course, in more detail in another video, the following video, I mean. Alright, see ya, bye bye.